Today we have Stuart Robinson with Radiodetection with us to help us unpack the 8200SG locator. This is the newest locator by Radiodetection that helps combine mapping and utility locating all in one pass. You're able to record exactly what you're locating, how deep it is, all the other locate elements, and get it down to an inch accurate. So help us unpack this, Stu, and welcome.
Okay, yeah, Travis, no problem. Yeah, this is our new RD8200SG, and this is based on the RD8200 platform. And this time we've added survey-grade GPS to it. It's the latest precision locator, and it allows you to locate and accurately map buried utilities. Now, we've called this survey-grade. What does survey-grade accuracy mean? Well, those that are familiar with survey terminology realize that we're talking about accuracy of less than 2 centimeters or less than an inch positional accuracy in good conditions. We've seen a significant increase in the demand for mapping. Our customers have said to us, hey, we're going out, we're marking out on the ground, we've got somebody following with RTK GPS, we've got 2 guys working, can you do anything for us? Helping with the workflow, we believe, is going to make this a very strong product in the market. Accuracy is very reliant on a number of factors, and we'll go through these: environmental conditions, vicinity to GPS, shadows, buildings, trees, stuff like this. But that's no different from any other GPS. And we can achieve 1 to 2 centimeter accuracy, less than an inch accuracy in good conditions. So what do we need to achieve survey grade accuracy? So we need the RD8200SG locator, and then we are going to use a mobile device. The mobile device is our conduit, if you like, into what we call a correction service. And then we need a utility mapping app. Travis, there in the US, you've got Subsurface Maps. It doesn't matter which app you use. So look for the app you're going to get the best support from. That's going to work for you. The app is almost irrelevant who makes it. And then as long as our locator talks to that app, they all work in exactly the same way. Then we need what we call a correction service provider. So we're using premium positioning in the UK. Point 1 navigation is good in the US. You can use Trimble, you can use SmartNet, you can use Topcon, anybody that's providing one of these correction services. So changes from the RD8200G. We have, as you would expect, a new higher accuracy GPS antenna. Then we have a high accuracy GNSS board. There's dual-sided carriers for the mobile device bracket. And there's a spirit bubble to aid positioning so that your locator is upright.
The spirit bubble.
The spirit bubble, the bubble on there will just give you a little bit more accuracy. So if we switch on, go into the menu, you'll all be familiar with the menu. And now in GPS, we have, instead of internal, we have RTK. Now, RTK is our high accuracy GNSS. RTK just means real-time kinematic. So real-time kinematic is a term you will hear. It basically means your position is real-time as you are moving. So it's high accuracy in real time, and the kinematic part of it means as you move. Now, the major difference is in information. If you go into information, you'll see a new heading, and that is MAG-H, and that's a magnetic compass. The reason for the magnetic compass is we need a direction, and we need that direction because we have an offset. The center of the antenna is 7 inches, 18 centimeters from the center of the blade. So to get that offset in the correct direction, we need to set a magnetic compass. Now, don't worry about any of this, because when it comes out of the factory, all this is set correctly for you. Well, we'll go through a few things here, which you may need to, for troubleshooting, we may ask you to go through, or if somebody messes up with your settings, you may need to fix yourself. So if we go into info and go into version and go into MAG-H, make sure it's on, and we can go to check. And if we check it, we just need a compass. I've used a mobile phone, and we can turn this round. We've got 280, 320, and we've got a match, so that's good. Now we do have a reset on this. So if we go into reset, and why would we need to reset the magnetic compass? Well, you may be working in some environments and we haven't done enough work on this. We've had to put a reset in there. And it may be that if you're working inside a 400 kilovolt substation, really high levels of magnetic interference, it could throw the compass out. So to reset it, it's a bit like resetting the compass on your mobile phone. You've just got to turn the locator around and pick up 50 points. So turn it around on the spot. When it's picked up 50 points, it will give you a heading. So we're going to turn this. We're going to try and match it with north. Yep, it now matches north. So we're good to go. We've reset our compass. We're going to talk now a little bit about GPS fix and satellites. So you may be familiar with this. If you look on your locator, you will see on the right-hand side on the screen, you have an indicator of the GPS being active and seeking satellite lock. And then when we've acquired satellites, then we could indicate 3 to 5 fixed satellites, 6 to 8 fixed satellites, 9 to 11 fixed satellites, or 12 or more fixed satellites. Now, we don't indicate when we get to 12 as having any more. I was doing a GPR demo last week and I had 26 satellites. So you may be getting up to that kind of number. But we know we've got 12 or more there. GNSS and positioning terminology. Again, apologies, this is kind of 101. This is a very simplified look into how GNSS works and some of the positioning terminology to help you, for those that have not come from the survey world, to understand a little bit about what's going on. So GPS. GPS is actually what we call a generic trademark. It is an acronym and it comes from the US Navstar system. So Navstar, it was the Navigation, Signal and Time and Ranging Global Positioning System. And since it was the first one, everybody's then referred to everything that's GNSS as GPS. So the more accurate terminology is GNSS, which means Global Navigation Satellite System. Now that, another acronym, it's a coverall. It's a coverall for any of the constellations that are providing accurate navigational information to any device with a GNSS receiver. And they all use a single coordinate system. This is known as WGS-84. And that's the World Geodetic System, which was established in 1984. And it's a standard that's used in survey. So the current version, it's Earth-centered and it's a fixed system and describes the Earth's gravitational model and the world magnetic model, and it creates a survey or a grid system of the whole globe. Survey grade. We've gone over this, so we're talking 1 to 2 centimeters and under an inch accuracy. Uncorrected, standard GNSS is 2 to 3 meters. When we correct it, it can be less than an inch. As I said, real-time kinematic. It's the application of a correction service to take away errors. So it just means you're getting an accurate position real time whilst you move. So we get 2 types. We've got fixed RTK, and this is where we've got our good fixed solution and where we're getting our highest accuracy. And then we have something called float RTK, and we'll mention float later on. This just means that we're getting some correction data, but it's not yet moved to the highest precision mode. So when you're in float, you'll probably be within 18 inches, 20 inches.
I mean, I really find that you need to wait for the fix. So, I mean, the float, it can float in any direction. So it's not like it floats always in the same direction. You can compensate for that. You know, there's a big difference there. It's just, it's uncertain. So, I mean, you don't want to keep saving uncertain readings. So
no, I mean, I find that float is absolutely fine for asset management, where if you want to say, there is a lamp column and it's here. If
Yep.
you're within 18 inches of it, you can see it. But for accurate underground survey, no, you want it fixed. This is something you're going to hear as well. NTRIP, Network Transport of RTCM via Internet Protocol. Now, RTCM just means Radio Technical Communications for Maritime. That's just the GPS signal. It's actually owned by NEMA. We call it a NEMA string, and that's the National Maritime Electronics Association. So all of these acronyms, all it means is we are getting our corrections over the internet. We're transporting the corrections over the internet. And this is how we get our corrections. So there's three main parts to an NTRIP system. There's the server, and this gathers data from permanent base stations. There's the NTRIP caster, and think about fishing. It's casting out the correction data. And you're the client. So if you're an NTRIP client, you're allowed to use that data, and that's why we need the correction service and a license. Now, traditionally, GPS, what we used to do to get corrections, we used to set up what we call a base station. And that base station, we would have our base station, what we called our rover, which in this case would be the locator. And we'd put the base station on the ground and leave it there. And we communicate via radio. So we'd have to buy 2 GPS systems. And GPS can be accurate to a millimeter if you leave it in the same place for long enough, because it's constantly refining its position. So about, nearly 20 years ago now, when the internet we're starting to get decent speeds, and we decided what we could do is use a series of fixed base stations. Instead of owning our own GPS, we could use fixed base stations that know where they are and connect to them via the internet and have our two-way communications via the internet. How it basically works is you've got a reference station that knows exactly where it is, and you've got a rover that kind of knows where it is within 18 inches. Now, if you're close enough, and this is what we call a baseline, to your nearest reference station, then it's getting the same signals that you are. And it knows instantly how far out the information it's getting is. And it kind of rings you up and says, hey, that information you've just had, you need to be 5 inches to, 5 inches X, 4 inches Y, and that's a correct position. And it instantaneously sends that correction because it knows exactly where it is. And it's constantly sending you those corrections. So that's why we have the fixed reference stations that sends its data to the server. The server then sends it out via the caster to you. So there you have an accurate position.
And it's not like you need to know where these reference stations are. I mean, it's nice to know, but just when you hook into the server or dial into the server, it's going to figure out which reference station is the closest to your location, because your GPS is sending your location, right? And then it's then pairing you to the closest solution automatically.
Yeah, and typically it's, we say 50 to 100 kilometers.
Yeah.
So,
what is that in miles?
Well, 100 miles, 160 miles, 160 kilometers, 100 miles. So 80 kilometers is 50 miles.
Yeah.
So it's going to be 30 to 60 miles.
I mean, I hook into an Iowa base station here, and it's about 24 miles as the crow flies from our office. And as an example, and being that far away, it will make a difference of about 1.5 inches of play. So the further away you are, of course, the more you're going to be, the more error you're going to introduce into your solution, but you can still use it if you're happy with that.
So we're talking about a constellation of satellites providing signals from space, and it's actually clocks on satellites So you can establish any position on Earth if you have fixed known positions above you, and you know exactly how far away each of them is, and they will intersect to one single place. So GPS has 31 satellites. You need a minimum of 24 to establish a constellation. Russia has 24, Europe has 24, the Chinese have 46, so they've got lots of redundancy. So how does it work? We've got the space segment, and we have to have a minimum of 24 satellites orbiting every 12 hours, and this allows at least 4 satellites above a 15-degree cutoff angle at any point of the surface of the Earth. Experience shows us that we normally have 5, often 6 or 7, but that if we're just working with Navstar GPS, because we're also working with Galileo and GLONASS, it's not unusual to see 15 plus. So a lot of the time, you're just going to see 12 plus satellites. There's a control segment in Colorado Springs for GPS, and then there are 4 base stations. There's 4 ground antennas roughly on the equator. So these control stations track the satellites and update the positions and calibrate and synchronize the clocks. Then the user segment is anybody using it. So it could be you and your car, it could be marine navigation, or it could be collecting data with the 8200SG.
Now that, when you're just have the antenna on and not using RTK corrections, that you are still getting some corrections, right?
You can get, so we'll be using EGNOS in the, I don't know what the US one is, but EGNOS is the European geostationary satellite. So it's a single satellite sending corrections. You can use EGNOS in Europe with most things, and the US will have something similar.
Some DGPS, but and so I've noticed that it just natively without any corrections coming in, I'm getting down to about 1.5 foot, which is actually pretty remarkable for the
well, if you stay in the same place long enough, it'll get better. And we actually monitor dam movement with GPS because they just stay where they are, they don't move. So here's just a little bit of a visual of what's going on. We have our rover, our base station, our server. We got a bunch of satellites here, and they're all transmitting. And the information from the base station is going into the server. That then sends its information up to the caster. The caster's sending that information out, and we're receiving correction data. And all this is happening at exactly the same time. So it's instantaneous, or almost. Error. Now, of course, there are errors. So what causes the errors? We got ionospheric and atmospheric delays, satellite and receiver clock errors, and multipath errors, and something called dilution of precision. So this is why we get ionospheric delays, because the ionosphere refracts the signals a bit like light through a prism. Now, if we have low satellites or low profile on our satellites, low elevation, well, they're going to pass through more of the ionosphere than satellites that are directly above us. Receiver clock errors, satellite and receiver clock errors. Now, even though we're good to about 3 nanoseconds, light signals travel about 0.3 of a meter or a foot in a nanosecond. So this is why the base signal can be a bit out, because 3 nanoseconds, the clocks are accurate to about 3 feet. And they can drift, so we've got to keep the clocks as accurate as possible. And the control station monitors this and sends the corrections to any affected satellites. Then we've got something called multipath errors. And I think this diagram outlines it quite clearly. The same signal we're receiving with the antenna is also bounced off a building. It could bounce off trees, it could bounce off a lake. And we're receiving the same signal, but that signal's gone further. So this is what called multipath errors. Dilution of precision, and this is to do with satellite geometry. So if you've got satellites which are too close together, then you get a larger dilution of precision. And if you've got a good spread of satellites, you get a smaller dilution of precision. Now it's measured in several ways. You've got horizontal, vertical, positional, time, and geometric. What you're looking for, though, is a value, and you will see normally on your app, you will see the PDOP, the position dilution of precision. And you want this in or around 1, certainly less than 2. And as the DOP value goes up, how much you can rely on a position goes down. So normally you will see RC DOP values of below 1, 1.1, things like that. And we're really confident about the accuracy of those positions. So now back to the locator. How do we set it up and how do we connect it? So if we switch on, the first thing we need to do is go into the menu. Now this setup is already done for you. So when this comes out the factory, this setup is already done. So this is in case anybody messes with it. GPS, RTK needs to be on. Then we need to switch on our mobile device, switch on the Bluetooth, and go to scan. Now, the first thing you're going to see, we've got 2 Bluetooth connections. One is the locator, and the other one is the GNSS board or the RTK board, because we've got 2 data streams coming. We've got a positional data stream, and then we've got all the data from the locator. So we've got 2 types of data. We've got location data and positional data, and they're coming from 2 different boards. So we go into pair, the RTK, and cunningly, the password is 1234. And those that know anything about Bluetooth, it's always 4 zeros or 1234. Now, what we need to do is activate the Bluetooth on the locator. So we go into SM log. Now, as I've said, this is already set, but it's something to check if something's going wrong. The protocol we normally use with this locator is we want to use ASCII, or we want to use ASCII 2. Now, I'm going to go into pair. Now, I put the locator into pair, and we'll see the Bluetooth symbol flashing on and off on the locator. Now we scan with our phone again, and now you'll see the same locator, but it doesn't have a prefix of RTK. And we pair that one, 1, 2, 3, 4, out of Bluetooth, out of connections, and back home. And that's it, really. It's not overly complicated, and it's just giving you the benefit of being able to precisely locate or precisely map what you're picking up in real time.
All right, I got Evan and Emma here. So Evan's going to take my locator out with my phone, and I'm going to show you. I guess we can go over Subsurface Maps and the application, and as he's clicking away, and Emma can go ahead and share your screen, turn your video on. So he's selecting the map to go into, to draw to, and these are downloadable maps that you create when you get on subsurfacemaps.com and log in. You would already predefine everything that you want to do. You can go ahead and create the map or the work area that you're working in, and color code. Set all your utilities up that you know you're going to collect. But it's in float mode right now, and this is the float mode that you were talking about, Stu, earlier, about how you get about a half a foot, but we really want to wait for a fix to happen. And the current location where he's standing is where the yellow X is currently there. And the fix should happen as soon as he gets away from the building, probably a little bit. And there we go. You can see as when you get RTK fix, it jumps right down to 0.03 of a foot, which is, what is that? Under an inch. So it's repeatable. You know, the thing is, you're not just mapping the utility line, you are also maybe using the same GPS to go back and relocate. And we can do that in a bit. But now he's going to go in and he's going to draw in what he wants. And the subsurface maps draws to 2 layers at once, because you have points and you have lines as you're locating. And so you select what type of line you're locating, and then the points layer will be the different points you come across as you're doing that line. So if you're locating a power line in and out of a pedestal or through a vault, a manhole, those are points. So you want to put them in as that. But in between, you're taking depth points. You're just adding depth readings and saving the depth and the location as you're moving along. So he's going in here and selecting the 8200, same serial number, but without the RTK. He's just selecting the Bluetooth module that's going to pull in all that locate information, and it says waiting for connection right now, and start the locate. I believe he's probably going to go on power mode and just locate out the power line that's in front of the building here. But he'll go ahead and he'll push the button, and so once that form pops up, it will transfer. Even though the locator is reading it in feet and inches, it will transfer it to straight inches, and you can see it's 45 inches there. He's going to put in power and lock this attribute because you want it to repeat the name power, and it could be anything you want. It can say 3-phase primary or have a certain number to it. But anytime you lock the field, if you know you want to repeat that same information on the next one and the next one and the next one, it will automatically fill that info. It's all about workflow. You want the locator to not be boggled down with any extra work. They're not going to be happy having the GPS on top of doing the paint and flags. So make it easy for them, and they're going to see the benefits after a while as they're doing it. They're going to see this information that's under an inch accurate to be repeatable when they go back and do this locate again in the future. So we're on to our second reading. He hit the button again, got 43 inches, and now he's moving on to the third one. You don't have to hit the add button. It will automatically add it for you as you're going along. Just keep it right there, Evan. All right, so when you're done with this survey, you would just hit the stop done button up on the top, and you add the last reading you just took, and then hit stop done up on top, and you'll see that I don't know if I should do this, or I'm going to zoom in and it's going to mess him up, even though he's outside. You can see the red line that's been created down below here, and where it's been. And now, if you would want to sync this up to the cloud, so everything is cloud based. So go ahead and close that, Evan, and go back to the menu, and up on the top left, go back to our maps where we started. And he's just going to hit the sync button to the right of the basic demo map that we were using. And this is going to upload all the depth readings, upload everything that we did, the pictures that we've taken, everything, and to the cloud. And then after it's done uploading your user info, it will download what anybody else has changed. So the nice thing is 3-4 different people can be working on the same job, locating and mapping, and they just keep updating the map by doing the sync, and they're able to see what still needs to be done, what gaps they need to fill in, and the workflow makes it nice and easy. But once it's up in the cloud, it's safe too. That's the nice thing about working in a cloud environment. You're not saving the information on the phone that can easily be dropped onto the concrete or dropped into a pool on accident, and you lose all your data for the day before you had a chance to download it or send it. With the cloud-based system, thanks, Evan. You can go ahead and sync it anytime throughout the day. It just takes a couple seconds and be done with it. Once it's in the cloud, you can break your phone all you want. The information's safe. This is kind of a good example of, they went through there, located it with the SG, and put it up on the cloud system for Subsurface Maps. So they had several technicians out there working simultaneously. But you can see by the color codes, they got the power, the water, you got the the communications, they even have steam lines and such in here, and the sewer lines. But it puts everything in perspective for every contractor that comes onto that job site from that point forward, back and forth between the two. So sharing is caring. So sharing your information, the better. It's all about communications with damage prevention. The more information you can communicate to the excavator, the more excavator information that can be communicated back to the locator back to the facility operator, everybody working together to keep all the utilities safe that are underground and hidden. So thanks for your time. You did a great
Yeah,
job
it's no problem, Travis.
everything.
Anytime.
I'm going to put this up on YouTube, and hopefully people can use this as a tool to understand, have a good grasp on what they're getting into when they're getting into a GPS enabled locator like this, or the SG.